Okay, welcome back to another video on the Maths channel. It's the teacher, Mr. Lim here. In this video, we're going to be looking at question 18 of the Caringbah 2020 trial for Maths Advanced. Consider the curve y equals 2x cubed minus 9x squared plus 12x. Find the coordinates of the stationary points and determine their nature. So to determine the stationary points, we need to differentiate and make f dash of x equal to 0. So we're going to have y dash is equal to 6x squared minus 18x plus 12. The stationary points is when y dash is equal to 0. So we've got 6x squared minus 18x plus 12 is equal to 0. I'm going to divide everything by 6. This gives me x squared minus 3x plus 2 is equal to 0. And now I can factorize this. X minus 2 and x minus 1. So x has to equal to 2 and 1. Now, when x is, I'm just going to do that over here. When x is equal to 2, y is going to equal to, I'm going to sub that into the original function. So we've got x equals 2. So we've got 2 answer cubed minus 9 answer squared plus 12 answer is 4. So 2, 4 is a stationary point. When x is equal to 1, y is equal to 2 lots of 1 minus 9 lots of 1 plus 12 lots of 1, which is 5. Okay, so we've got 2, 4, and we've got 1, 5. What we need to do now is determine their nature. So nature. What we can do for this is we can work out the second derivative, and then we can sub these x values in to determine whether it's greater than or less than 0, and therefore whether it's a minimum or a maximum. So y double dash, I'm going to differentiate this now with respect to x. That's equal to 12x minus 18. So when x is equal to 2, y double dash is going to equal to 12 lots of 2 minus 18, which is equal to 6, which is greater than 0. Therefore, it's a minimum turning point. When x is equal to 1, y double dash is equal to 12 lots of 1 minus 18, which is negative 6. That's less than 0, and therefore that's a maximum turning point. So I'm just going to write here, just to conclude, 2, 4 is a minimum turning point, and 1, 5 is a maximum turning point. Now, you don't have to use the nature, you don't need to find the nature in that way. You could have found it in a different method. Let me just show you quickly. So here's an alternate method. What we could do is work out f dash of x for the values surrounding these x values of 1 and 2. So I'll just say 0, 1, 1.5, 2, and 3. And then we can determine its slope and just graph it. So we know f dash of x for 1 and 2 are both 0. What do we get when we sub 0, 1.5, and 3 into f dash of x? Now, f dash of x, or y dash, is 6x squared minus 18x plus 12. So I'm going to sub that value in there. When x is 0, f dash of x is 12. When it's 1.5, we've got 6 times 1.5 squared minus 18 times 1.5 plus 12, which is negative 1.5. And when it's 3, 6 answer squared minus 18 answer plus 12. It's positive 12. So we can see from here it's sloping up, then it's got a horizontal gradient, sloping down, horizontal gradient, sloping up. And so we can see when x is 1 or 1, 5, it's a maximum turning point. And when x is 2, it's a minimum turning point. So 2, 4 is a minimum turning point. So it's up to you which method you want to choose. Question B. Show that a point of inflection occurs at x is equal to 3 on 2. So a point of inflection is when f double dash of x or y double dash is equal to 0. So we've already worked out that y double dash is equal to 12x minus 18. So the point of inflection is when y double dash is equal to 0. So 12x minus 18 is equal to 0. 12x is equal to positive 18. X is equal to 3 over 2. Now that's not enough to show that's a point of inflection. We actually need to show that concavity changes. So I'll have x and I'll have y double dash. And I want to test to see whether the concavity changes around this point. So I'm going to say 1, 3 over 2 is 1.5, and 2. Now we know that y double dash for 3 over 2 is 0, so I'm just going to put that in right now. What is y double dash when x is 1? So when x is 1, we've got 12 lots of 1 minus 18, which is negative 6. So that's concave down because it's negative. When x is 2, we've got 12 lots of 2 minus 18, which is positive 6. That's concave up because it's positive. So I'm just going to write here concavity. And now that we've done that, we can say, therefore, there's a point of inflection at x is equal to 3 over 2. Okay, part C. Sketch the graph y equals 2x cubed minus 9x squared plus 12x, indicating all important features. So I'm going to write down the important features first. I know that there's a maximum turning point at 1, 5. I know there's a minimum turning point at 2, 4. And I know that there's a point of inflection at x equals 1.5. I just don't know what y is. So let's work that out. When x is 1.5, y is equal to 1.5, 2 answer cubed minus 9 answer squared plus 12 answer 4.5. 4.5. Okay, another important feature is probably the y-intercept. So the y-intercept is when x is equal to 0, which in this case is just 0. Okay, so let's see if we can put all this information in. 1 and 2. We've got, it goes up to 5. So let's say 1, 2, 3, 4, and 5. Maximum turning point at 1, 5. Minimum turning point at 2, 4. And a point on inflection at 1.5, 4.5. So we know it's going to be concave down on this side, and it's going to be concave up from here. So what I want you to do, I just want you to get used to labeling all our points. I'll just say that that one there is 1.5, 4.5, and here we've got 1.5. Okay, that's it for question 18.